We choose to examine a phenomenon which is impossible, absolutely impossible, to explain in any classical way, and which has in it the heart of quantum mechanics. In reality, it contains the only mystery. Richard Feynman, a Nobel laureate of the 20th century, Radin, Dean. Entangled Minds, Extrasensory Experiences in a Quantum Reality. New York, Paraview Pocket Books, 2006. The concept of time is a weird one, and the world of quantum physics is even weirder. There is no shortage of observed phenomena which defy our understanding of logic, bringing into play thoughts, feelings, emotions, consciousness itself, and a post-materialist view of the universe. This fact is no better illustrated than by the classic double-slit experiment, which has been used by physicists repeatedly to explore the role of consciousness and its role in shaping, affecting physical reality. The dominant role of a physical material Newtonian universe was dropped the second quantum mechanics entered into the equation and shook up the very foundation of science, as it continues to do today. I regard consciousness as fundamental. I regard matter as derivative from consciousness. We cannot get behind consciousness. Everything that we talk about, everything that we regard as existing, postulating consciousness. Max Planck, theoretical physicist who originated quantum theory, which won him the Nobel Prize in Physics in 1918. There is another groundbreaking, weird experiment that also has tremendous implications for understanding the nature of our reality, more specifically, the nature of what we call time. It's known as the delayed choice experiment, or quantum eraser, and it can be considered a modified version of the double-slit experiment. To understand the delayed choice experiment, you have to understand the quantum double-slit experiment. In this experiment, tiny bits of matter, photons, electrons, or any atomic-sized object are shot towards a screen that has two slits in it. On the other side of the screen, a high-tech video camera records where each photon lands. When scientists close one slit, the camera will show us an expected pattern, as seen in the video below. But when both slits are opened, an interference pattern emerges. They begin to act like waves. This doesn't mean that atomic objects are observed as a wave even though it recently has been observed as a wave, they just act that way. It means that each photon individually goes through both slits at the same time and interferes with itself, but it also goes through one slit, and it goes through the other. Furthermore, it goes through neither of them. The single piece of matter becomes a wave of potentials, expressing itself in the form of multiple possibilities, and this is why we get the interference pattern. How can a single piece of matter exist and express itself in multiple states, without any physical properties, until it is measured, or observed? Furthermore, how does it choose which path, out of multiple possibilities, it will take? Then, when an observer decides to measure and look at which slit the piece of matter goes through, the wave of potential paths collapses into one single path. The particle goes from becoming, again, a wave of potentials into one particle taking a single route. It's as if the particle knows it's being watched. The observer has some sort of effect on the behavior of the particle. This quantum uncertainty is defined as the ability, according to the quantum mechanic laws that govern subatomic affairs, of a particle like an electron to exist in a murky state of possibility, to be anywhere, everywhere or nowhere at all, until clicked into substantiality by a laboratory detector or an eyeball. New York Times. According to physicist Andrew Truscott, lead researcher from a study published by the Australian National University, the experiment suggests that reality does not exist unless we are looking at it. It suggests that we are living in a holographic type of universe. Delayed choice, quantum eraser, time. So, how is all of this information relevant to the concept of time? Just as the double-slit experiment illustrates how factors associated with consciousness collapse the quantum wave function, a piece of matter existing in multiple potential states, into a single piece of matter with defined physical properties, no longer a wave, all those potential states collapsed into one, the delayed choice experiment illustrates how what happens in the present can change what happens in the past. It also shows how time can go backwards, how cause and effect can be reversed, and how the future caused the past. Like the quantum double-slit experiment, the delayed choice, quantum eraser has been demonstrated and repeated time and time again. For example, physicists at the Australian National University (ANU) have conducted John Wheeler's delayed choice thought experiment. The findings were recently published in the journal Nature Physics. In 2007, Science 315, 966, 2007, scientists in France shot photons into an apparatus and showed that their actions could retroactively change something which had already happened. If we attempt to attribute an objective meaning to the quantum state of a single system, curious paradoxes appear. Quantum effects mimic not only instantaneous action at a distance, but also, as seen here, influence of future actions on past events, even after these events have been irrevocably recorded. Asher Perez, pioneer in quantum information theory. The list literally goes on, and was first brought to the forefront by John Wheeler, in 1978, which is why I am going to end this article with his explanation of the delayed choice experiment. He believed that this experiment was best explained on a cosmic scale. Cosmic scale explanation. He asks us to imagine a star emitting a photon billions of years ago, heading in the direction of planet Earth. In between, there is a galaxy. As a result of what's known as gravitational lensing, the light will have to bend around the galaxy in order to reach Earth, so it has to take one of two paths, go left or go right. Billions of years later, if one decides to set up an apparatus to catch the photon, the resulting pattern would be, as explained above in the double-slit experiment, an interference pattern. This demonstrates that the photon took one way, and it took the other way. One could also choose to peek at the incoming photon, setting up a telescope on each side of the galaxy to determine which side the photon took to reach Earth. The very act of measuring or watching which way the photon comes in means it can only come in from one side. The pattern will no longer be an interference pattern representing multiple possibilities, but a single clump pattern showing one way. What does this mean? It means how we choose to measure now affects what direction the photon took billions of years ago. Our choice in the present moment affected what had already happened in the past. This makes absolutely no sense, which is a common phenomenon when it comes to quantum physics. Regardless of our ability to make sense of it, it's real. This experiment also suggests that quantum entanglement, which has also been verified, read more about that here, exists regardless of time. Meaning two bits of matter can actually be entangled, again, in time. Time as we measure it and know it, doesn't really exist. And if you want to learn more, I recommend you click the link in the description. From www.power-quadrant.blogspot.com/ and if you like this video, please give it a thumbs up and subscribe and share it with your friends on Facebook and Twitter and Google+. Thank you for watching and see you next time.